Welcome, everyone. I have to admit, I'm one of the guys that said to Gil, "What's the connection?" I was polite enough not to say it like that, but I was thinking it. Because we have, at least my company, we're an engineering company, we build projects, the technology, at least on the face of it, is well understood. And it was difficult for me to identify specific challenges that could be of interest, and we could get solutions from the people in this room. I'm sure that's a lack of imagination on my part. So what I thought would be the best thing to do would be just explain a little bit about what we're doing and let you guys come up with the solutions for the problems that we have and maybe didn't think about yet. So that's what I'm going to do today. The other thing I can mention, just as more of a traditional IT consumer that we're using a lot of telecommunications. All of our systems all of our stations are not manned. So we have a central control room in Tel Aviv where we operate by means of a SCADA system, stations from Haifa down to the Dead Sea. So that we're technology consumers in that sense. Let's start out by just explaining what INGL is all about, because not everybody knows about INGL yet. We are a government company. We're 100% owned by the government of Israel, by means of the Ministry of Energy and Infrastructure. We've been in operation since 2004. We started operations at the same time as Yam Tetis did, so we kind of hit the ground running. We didn't have a lot of time to get organized before we were required to do a job, and we've come a long way since then. We started out with 8 people. We're now up to about 100. We are a regulated monopoly, so our revenues come from a fixed transmission tariff that's paid for by the shippers, who are the consumers of the gas. And we're subject to regulation by the Natural Gas Authority, which is part of the ministry. Our facilities are both onshore and offshore. We've got pipelines currently up until 30 inches diameter. You can see here a couple of examples. We've got 3 receiving stations, one of which is active now in Ashdod, the one in Ashkelon, which was formerly taking the gas imported from Egypt, now not in operation. And we have an offshore receiving station for LNG, liquefied natural gas, which we built offshore Hadera, which is an interesting project in itself, but that'll be for another day. Today I wanted to focus on future challenges, so that's we did that one already. Other facilities that we have are pressure reduction and metering stations. These are at each customer or at each entrance to a distribution company. We have a connection with the customer. The function of these stations is to reduce the pressure to the pressure required by the customer. At the same time, because of the Joule-Thomson effect, we need to heat the gas because otherwise it gets too cold and we have hydrates. And of course we meter the gas. So there's various metering technologies that we're implementing, turbine meters and ultrasonic meters, sometimes also Coriolis meters. And about every 10 kilometers along our system we have block valve stations. It's for the purpose of isolating segments of the system in case there's some kind of emergency. We're not allowed to have more than a certain quantity of gas exposed if something happens to the pipe. So we can remotely from Tel Aviv, we can stop the gas. If there's a rupture in a certain location, we can close the valve before and after and limit the quantity of gas that's released to the environment. In total, we have 435 kilometers of pipeline in operation. Of that, 90 kilometers is offshore, connecting between Ashdod and Dor, and the rest is onshore. It goes from the Dead Sea in the south up to Haifa and Alon Tavor in the north. So we're covering most of the country, certainly the industrialized areas of the country. 2 receiving stations, 1 deep water port, 28 block valve stations, and 22 PRMSs. All this we built in 9 years. So we're proud of that. We think it's not so easy to build infrastructures in Israel, certainly in the densely populated parts of the country. This is what we've achieved so far. Again, since we're talking about the future today, just to give you the idea of what's involved in making all these pipeline projects happen, I'll bring you a few pictures. So if maybe someone in this room will see something that we could be doing better or more efficiently, and we'll be happy to know about it. This is just showing what it looks like to lay pipe. What you do is you clear the right-of-way. It's a long strip of land. You lay out the pipe. The pipe comes in sections between 12 and 14 meters long. You lay them down next to the right-of-way. You trench. You make a trench of approximately 2 meters in the ground. And then you weld the pipes together and put them in the trench. Steel is an amazingly flexible material. I have another picture that I didn't show you. You can see it bends like spaghetti. So you can make very long strings and then pick them up and put them in the trench. It's no problem. The picture on the right shows sometimes we have to go a little bit deeper. This is a pipe that we excavated in Ashdod to check something. So sometimes we're working at considerable depth. A lot of our customers are in the southern part of the country, so we have to work in the desert. And here you can see the terrain that we needed to cross. Some of the construction instruments that are involved in that. We work offshore, not at the depths that Noble is working at. Certainly, and I have to say, every time I hear about the Tamar project, I'm impressed all over again. It's amazing, 1,700 meters of water, and we had a little bit of experience in shallow water. Our pipeline is between 30 and 50 meters. The LNG buoy is in 73 meters, and so we got a little taste of what Noble's doing. We're working with divers, working a little bit with ROVs. So some of those technologies are applicable to us as well. This is when we put the buoy in the water. It was 5 vessels working at close proximity to each other, coordinating between that and make sure that everything worked the way it was supposed to was a management challenge and a technical challenge for us. The buoy is connected to the seabed with a mooring system that's based on suction piles. And what that means is that instead of traditional anchors, which are weight or piles that are driven into the ground like nails, this is kind of like an upside down cup. So these steel cylinders are 18.5 meters high, and we place them on top of the seabed. The seabed is very soft at that location, and partly under its own weight, and then afterwards by means of pumps, we pumped out the water from these piles and nailed them into the ground, and that is what is holding right now the 300-meter vessel that you see offshore of Hadera. That is its mooring system. So this is kind of a unique technology that we used here. I don't think it had been done in Israel before. So the future. The first thing I wanted to show is that, and I think we saw these numbers earlier in the morning, but the point is that the gas market in Israel is big and it's growing fast. Basically, almost all of the new build electricity generation is going to be on gas. There's going to be conversions from coal to gas. There'll be some renewables in the mix, of course, but almost everything that's going to get built here is going to be gas. The other thing is the distribution companies, which have been started to operate now. So their job is to connect the smaller customers, commercial customers, and small industry. That's going to be a tremendous engine for demand growth, and we see that in the numbers. We've got either between operation that came on this year and under construction that's coming on next year, 2,500 megawatts of independent power producers. That means Israel Electric is no longer the only game in town. So, and gas is the way that happens. So that's a tremendous source of customer. A lot of our customers are of that type. Companies that are making their own power and competing with the national electric company. The other one, which is new, is compressed natural gas. We've got 2 projects now for compressed natural gas. It means gas usually is delivered by pipelines, but the pipelines don't get everywhere, and they certainly don't get everywhere immediately. So there are 2 investors that are building stations to compress the gas, load it on trucks, and bring it around the country to customers. There's one in Ashdod and one in Alon Tavor under development, and those should come into operation sometime next year. The supply, we know we've got the supply. We heard about Tamar, Leviathan, the LNG, and we're sure there's going to be more discoveries offshore. So we've got the supply, we've got the demand, now we have to connect the 2. That's our job. So our pipeline system that we built in 2004 until today is, of course, needs to be expanded to meet the demand. And therefore, we have the following development program already being implemented. We need to build another 200 kilometers of pipeline in the next 3 years. It's going to be a pipeline along the route of Road 6 from Nesher, Gezer, until Chagit, 36 inches this time. That's going to provide operational flexibility to the system, redundancy, and additional throughput to the north of the country. We are uncomfortable with the current situation that the entire north of the country is served through one 30-inch pipeline offshore, which if something happens to it, it's going to take months to repair. The other pipelines here is one to Jerusalem, which is already in construction. If on the weekend anyone goes to the Burma Road, you can, in this area of the Jerusalem mountains, you can see the pipeline being installed there. We are doubling the line coming out of Ashdod. No surprise, we built our system with the idea that gas would be coming from Ashdod and Ashkelon and the north. Today, because of circumstances beyond our control, the gas from Ashkelon is no longer being supplied from Egypt. So we have all of the supply of the country coming from Ashdod and from Hadera. So the pipeline coming out of Ashdod is no longer the proper size. It's a 24-inch pipe. We are building a 30-inch pipe next to it to increase the capacity. The rest of these are customer connections. An important one in Palmachim, Nilit. Those are long pipelines to connect future customers, power stations. The other line that I added on the bottom here, additional looping in the south and the north will be required in the near future. So we're starting with the 30-inch line out of Ashdod, but we're going to have to double large parts of our system in order to keep up with the demand. Nobody knew in 2004 when we started how much gas was going to be discovered here and how quickly it was going to take over the energy market. So we're finding ourselves going back to corridors that we put pipes in 5 years ago and having to put another pipe in the same corridor. So we're happy to do it, and it's going to enable us to make a more reliable system and to keep up with the demand. Just to show a few of those pipelines here, you have the Eastern Pipeline. It's 90 kilometers along the corridor of Road 6, 36 inches. Connect the airport and connect the north to the south by a second route. We've got the pipe to Jerusalem, Palmachim, the Ashdod-Zurich looping. And Phoenicia is another important one. We all read about it in the papers last year, so we're connecting Phoenicia. That's also under construction at the moment. And the last one, so beside the development plan, is also ideas for the future. INGL is a pipeline company, but we see ourselves morphing into an infrastructure company, meaning any kind of midstream infrastructure that's required for the gas business in Israel, we see that is part of our role. So the next project that we had in mind is to build storage, onshore storage. We think it's important for strategically, operationally. Customers need to bridge the gap between day and night. We have the opportunity, the geological formation of salt dome in Mount Sdom. And we believe that that's an ideal location where we can build salt caverns. The technology is you have to bring water, which there's water in the area. You can use brackish water, it's no problem, salty water. And you actually pump the water down between 1,000 and 2,000 meters and leach out the salt. So you pump in water that's a little bit salty and you pump out water that's very salty, and you move your wellhead in such a way that you create these caverns. Each one of them between 300,000 and 350,000 cubic meters in geometric volume, and can store 50 million cubic meters of gas in each one. And we have in mind in the first phase to build between 2 and 4, and it can go up to 10. We're this year doing a pre-feasibility study with the help of a French company called Geostock, and starting the statutory planning, the TAMA, for it. It's not a small project. It's 3 to 5 years to build something like that once the decision is made. But if you don't start, you don't finish. We think that storage is important for the country. Again, we also what happened 2 years ago when the Yam Tetis field needed to be utilized more quickly than planned because the Egyptian wasn't supplying. All of a sudden we didn't have the gas that we've come to rely on. So we don't want to be there again. And operationally, if this field was in place tonight, we would be using probably 15-20% more gas in the country. In the summertime, we imported 7 cargoes of LNG this year, and the price is much higher than the Tamar gas. If we had this kind of a facility, we would be able to store the Tamar gas during the off-peak. Today we're using 60% of what we're using in the summer. So the extra could go in a hole in the ground and get saved for the wintertime and for the summertime, and avoid the need to import costly LNG. That's all I have today. Thank you.